All right, good afternoon. Apologies, always running late. You probably don't want to listen to me talk for 2 hours anyway. So where are we? This is week 3. Had people joining the course, so the lab deadline was extended to midnight tonight. So that's the week. The labs will be normally due at Sunday midnight, but this is Tuesday midnight, to give people who have joined the course a chance to do the week 2 labs. Someone asked in the forum, do you need to go to the labs? So the tutors aren't mostly doing assessment. So for most labs, you don't need to go to the labs for assessment. There will be a couple of labs further on. I think when we do JavaScript can get a bit funny to automark, a bit difficult to automark. So instead we use peer assessment, which will involve going to the labs. Do you need to go to the labs for reasons other than assessment? All right, so if you're on track for a HD in the course, yeah, your call. You're doing nicely. You're getting out the challenge exercises in 5 minutes. Yeah, you don't need me to tell you what to do then. If you're at the other end of the class, yes, you need to go to the labs. You need to take advantage of you need to be at the lab, take a huge advantage of this great resource for learning. So, your call, I guess, your decision, and you'll live with the consequences. But yeah, as far as assessment goes, most of the labs, you don't have to be there for assessment. Right. Shell. Last week's lab was just filters. This week's lab, there's one example of pipelines, and it's a great sort of programming pattern to learn to use. And you'll find yourself in future still using this programming pattern, even if you're mainly working in C or Perl or Python. You'll just poke out a Python via system or subprocess or backquotes in Perl. But we're going to show you in the lab. You get to see you get to write first a really trivial shell script, then one with arithmetic, one with a for loop. And that covers sort of the main sort of programming patterns for a while loop, a for loop, and just a pipeline. So they'll cover a lot of the work you'll do with shell scripts. Ooh, test. We'll just go through a few slides, refresh our memory a bit. Test. Test is this really weird program. Wait, let me run it on the command line. I don't know what that is or why, but let's scroll it off. Test. So test lets you say, some of you probably went home and wrote that in C or Python. Lets you give it Boolean expressions. But oddly, it doesn't print anything. Test never prints anything that stood out, as far as I know. It makes an unusual program. Also doesn't create files, doesn't send anything out on the network. Error message will go to stood error. But I just seem to have eliminated all possibilities for interacting with the world. The file system, the network, stood out. What's left? What other way can a Unix process interact with the world? Well, one is signals. It could send a signal to another process or messaging other processes. Test doesn't do that either. There is one thing left for test. So it's not it's completely shut off from the world. It's useful. What is that? It's exit status. So somewhere in test, in main, if the arithmetic expression there is true, it exits with status 0. And if it's false, could exit with status 1. You're thinking, wait, that's reversed, Andrew. Python and C, 0 is false. But in exit status world, 0 is true. Why is that? Because programs exit mostly to say either I'm okay, which you only need one value for, or to say something's wrong. And there can be many reasons something is wrong. So they use 0 to say everything was okay, and they use other values to say no, something is wrong. How can I use test? I can actually, bear with me. So I can join shell commands together. One way is semicolon. You put a semicolon between two commands, they just exit command 1, command 2. In this case, command 1 is executed, and command 2 is executed only if command 1 succeeds, exits with status 0. Oh, that's not good. And it's got the OR equivalent. So it's analogous to C, the conditional AND and OR of C, except the value there is different. There we go. All right, that was... What else can tests do? Tests can test if a file exists, if it's executable, if it's readable. You can actually do ANDs and ORs in test little language. You can do string comparison, numeric comparison. So as arguments, you can give text this little language of expressions, and it'll just exit 0 or exit 1 for you. So it's useful only within shell scripts, basically. You just about never use it on the command line. You will see that the designer of Perl loved this sort of syntax so much, he copied some of it into Perl. You can play with that. Sequential grouping. I don't think we need to talk about that. If case... Oh. Case we don't cover much in this course anymore. Case used to be really big among shell programmers because it doesn't, if statements generally involve executing a separate process, which is really slow. Case statements don't. It doesn't matter nearly as much as it did a decade or two ago. Oops. All right. I think we just need to show you some shell programming and give you more of the flavour of how to do it, what it's like. No, we'll leave that there. We'll start working on that. What is that called? Program.show. Excellent. All right. Let me show. Oh, I need a web browser. Will it give me a web browser? Come on, you can do it. Maybe you can't give me. Oh, come on. I'm getting nowhere there. Oh, maybe that'll do it. What happens when I can get a web browser? Oh, that's right. Of course it is. What else would it be? That's not my day, is it? I suppose Firefox is going to say the same thing. All right. Thank you. We don't necessarily need a web browser then. Would make more sense showing you a web browser. Let's suppose my favourite artist is in town, performing, and I want to buy tickets as soon as they go on sale. So I'd like to write a shell script that monitors a website. And as soon as a particular string appears, you're saying, Andrew, wait, you're looking for a string. Can we use a regular expression? Yes, yes we can. As soon as a regular expression matches this website, the shell script sends me email saying, Andrew, go and buy the tickets right now. Can we do that in the shell script? In one page, in a lecture header? Yes, we can, and will. All right, I don't have a network connection, probably, uni-wide. I've learnt never to rely on uni-wide. So, really, there is a wired connection here. I'll have to investigate that. This is, if you get to ask the general feedback for this university, tell them what it needs is more wired connections in lecture theatres. So, in this week's lab, I think you're using a shell script to get information from web pages. From the handbook, yes. And you're saying, thank you, Andrew. This is a really relevant exercise because I'll have to scrape handbook. No, it's not handbooks you will have to scrape in future life, but how much information is out there on web pages. Gigantic amounts. So if you can write just a little shell script to grab it from a web page somewhere, quickly, easily, in 10 minutes, how useful is that? So why have we done the handbook? Two reasons. So it's, it's close and the owner of the handbook's probably not going to yell at us. And two, you're familiar with that sort of stuff anyway. All right, so let's present this is the IP address of the ticketing website. Those who have done any networking recognise the IP address. All right, so that's actually not a proper, well, it is an IP address, but it's not one out in the broader internet. It resolves to the local host. What's wrong with that? It should work. Oh, I know. All right, there we go. wget. There are many programs that will fetch a web page for you. There are two popular ones. One's called curl and one's called wget. In the lab, I think wget's recommended. They're pretty much similar. Curl's actually a bit better if you want to do clever things. I probably should switch to putting it in the lecture notes. So wget saves to a file, but it has an option to say, put the output somewhere else, and if you put a dash there, it sends the output to stood out. That's sort of a convention. So if you want your output on stood out, you can actually try that. Some programs will create a file called dash, other programs will follow the convention and put it on stood out. There's another trick, by the way, just while I'm giving you little tricks. There's a file name which, if you open it, gives you the standard output of your program. So if you've got a program that says, no, I don't put stuff on standard out, you can fool it by saying, here's the name of a file, put your output there, and the operating system will have that output go to stood out. We'll see if that works. If programs do clever things, that'll break. But if they just do a simple open, it works, and there we go. It comes to standard output as well. All right, we'll go back to the simple way. All right. So given that, we're now looking at a tool, I think. So we've got a URL of the ticket. We'll say it's Ticketmaster. URL equals that one. And we've got a while loop, really, don't we? Ticketmaster. Let's spell it properly. That's not what I want. I want the loop to keep executing while it's not there. I don't know how to do that. Oh, and the artist. In fact, it should be artist regex, shouldn't it? We'll make the artist regex. All right, I'm a bit worried about spelling here. There we go. How about that? So let's try running it. It's not while then if, is it? Who remembers the syntax? You had so many keywords. While, do, done. If, then, else, elif, fi. I think I could make money charging for the cheat sheets for the exam, couldn't I? Because, so you don't have to freak out about remembering these things. But yes, you get cheat sheets for the exam. They'll remind you of all that syntax. And fair enough. I mean, if you forget something like that, it's a second away on the internet. So in the exam, we give you that much. But not the internet. Not the internet. Oh, no. Write the file. What's gone wrong here? Oh, right. What do we notice there? This is sort of a language design thing. We'll see this again. What happens if you misspell a variable name in C or Java, C++? What happens? You get an error message saying, you haven't declared that variable, Andrew. So if this was one of the languages like that, to be saying, Andrew, there's a variable artist there, you haven't told me what type it is. But shell, because it's created for use on the command line, and people do use variables in the command line, you don't want to go all the trouble of declaring variables, plus they only have one type anyway, so you don't declare variables. So the shell can't give me an error message there. I guess it could look at the whole program and see the variable was only used once. All right, this time for sure. Oh. What's all this stuff here? That's coming from wget. But how is that coming from wget? I've piped wget into egrep. Are we getting on top of this idea of different streams coming out of a program? So stood out from wget is piped into egrep. But wget, like all Unix program, has two streams, stood out and stdout. And it's using stdout for something slightly different. These aren't error messages. This is sort of diagnostic / debugging / extra information. I'm not sure why it does this by default. Really, I don't think I need to know by default this stuff, but it does. All right, I might know, if I'm lucky, that wget has a -q option to shut it up. What do you do if you don't know about wget's -q option, or say the Q key is spoken on your keyboard? I could send standard error to random file, but what's better than sending it to some random file if I don't want it? Come on, everyone likes dev null. Dev null. All right, so that should get rid of the random crap. There is a risk to that, by the way. There is a risk to that. If then there's an error message from standard error from wget, where does it go? Dev null. So don't go overboard about sending stuff to dev null. Sooner or later, your program will start producing error messages which you've never seen. So if you're just suppressing verbose debugging information, it's better to try and find the command line switch to do it, which wget does have. -q does that for wget. Oh. All right, shell debugging 101. What do I do now? I want to know what's happening in my shell program. Set -x, which will tell me about everything that's executed. Is he right? Oh, he is. So it's showing me all the things that executed. All right. So let's try this out. Wow, I hate this shell. Bash has a feature to do something with URLs. I should find out how to turn it off. It's really annoying. So this command exited with status 1. Why? Because Kesha tickets aren't on sale yet, apparently. So my control logic is wrong. I want exit status 0 if the string isn't there. How do I do that? How do I change that regex to say not in the thing? Can't really do that with the regex itself. So you can't, well, there are circumstances where it's possible, but in general it's tricky to fully negate a regex like this. But I think I can say egrep -v. Let's try that, see what that does. That inverts the match. Oh, we got a lot of output coming, but what about the exit status? Oh, it's 0. All right, there's a lot of output I don't want, but let's use dev null again. It won't wear out. So let's hit this running now. Oh. And my logic's wrong there too. I don't know what I was thinking. Wait, that can't be my fault. I don't know what you all were thinking. Why isn't it exiting? That's a little worrying. All right, we'll come to that in a second. What I wanted to do this, and we might stop it. I don't know where mail goes on this laptop. I might do that. So that the -n option says don't write a new line. So you're at a party on Saturday night, you want to impress someone, you can say, did you know about the -n option on new line? What am I thinking? You're not going to go to a party on Saturday night, you'll be home coding. I shouldn't have suggested that. Oh, come on. This has got worse. Sorry, I don't know what's happening on my laptop. All right, let's try running the program again. Oh, we've got a problem here. It's accessing the website as fast as it can. So it's just sitting in the loop, grabbing the website, Kesha there, no. Grab the website, Kesha there, no. Do you know what the technical term for this is? This would be a denial of service attack. This is basically what a denial of service attack looks like. Okay, you can't really do it with just one laptop. So people then generally have a swarm of laptops that have got viruses onto malware and have them all to do this. But people who own websites really don't like this, and it's a waste of your CPU and your bandwidth as well. Oh, I've got new mail. Okay. All right, we'll try that. So what do I do about that? I've said every time you have a shell loop, well, it's not just shell, this is really ini language. Don't busy wait. Don't run it as fast as you can. Bandwidth limit it. And you'll find lots of things you access, websites. You try hammering through the university's firewall like this, and it'll stop you almost certainly. It will bandwidth you, limit you. Well, bad firewalls get upset with this sort of accesses. We're inside the firewall here, so we don't have to worry. But so we'll say, even though you just sleep for a second or two, that's a lot better. So my shell script's there now sitting, ticking away. Fetch the website. Grep for cache. No. Sleep for 5. Do it all again. All right. How do I change the website? Wait a minute. Where does the website live on this laptop? var www. Oh, HTML. That looks good. All right, so let me edit this website and say, we're pretending this is Ticketmaster. Oh, look at that. Debian default page. It works. All right. Oh, what the read-only file? That can't be right. So I'm altering the website on my laptop to say Keisha tickets on sale. I'll write the file. Now I'm confused. Why can't I write the file? It's my laptop. Who owns the file? Root. So the owner of the file can read and write it. Can anyone else write to the file? People in the same group? No. User? No. So that's my problem. What am I going to do about it? So I could change my user ID to root. There's a program called sudo on Linux that does that. But I'm already in the editor. That's a bit of a pain. Other suggestions? I could change the file owner. So I can do something like this for those of you getting into Linux. That should do it. Oh, apparently not. Oh, it's not my day. What is going on here? Oh, come on. Yeah. Sorry. Well, that's not going to help, is it? So the issue is it's trying to do network accesses. Bear with me. This will be on the exam. All right. All right. I've changed it to owned by me. Now I should be able to write the file. Stupid editor. Really do what I say. Oh, there we go. Oh, wait a minute. Let me write the file. Let's have this demo work. All right. So my program is sitting there fetching the website. Every time it fetches the website and there are no tickets, it just puts a little dot there so I know it's still alive. I write the file now. Now the website contains the string Keisha and it's going to stop. Come on, stop, stop, please stop. I think it's hung trying to send mail. It's not my day. No. All right, let's try and debug this. Oh, egrep minus v doesn't do what I want either. So my logic's broken again. See how in debugging a shell script you've got to pull out the individual commands, run them in isolation to really have any hope of what's working out what's going on? All right, I'm a lazy programmer. Let's go to my favourite programming pattern. While true. That's the equivalent of while 1 in C. Then I can do it, let's state this in the positive. I'll get rid of that. Oh, we're going to exit too, don't we? Not sure we've seen that. Look at that. We can be good in case we run from a shell script. If we ever get to there, we can have an exit 1. There we go. All right. It's not a bad example. Questions about that sort of programming style. That's where this notion of shell looking at exit status, just wrapping a small amount of control code around existing programs like wget and egrep works great. If this is something you're going to be using hundreds of thousands of times, you might convert it into Python, say, or C. If it's something you have to use once because you only want to see Keisha once, I guess. It's once a year, that's fine. No? Are we happy with that? Let me move to a different problem if we're happy with that. All right, I've moved to another directory, and there's been an unfortunate accident. All the file names in the other directory have been converted to uppercase, and there's a lot of them. This is actually a common use for scripting in shell. is you've got a whole pile of file names coming from somewhere and you mean to move them somewhere else, or they have to be changed slightly. For some reason there has to be an update to the work with program B or something like this. Or in this case, we want to convert them to lowercase. How would you do that? Well, you could get there in your GUI program, your file explorer or whatever, and sit there painfully typing them down to lowercase. A, we've got better things to do. B, we hate doing things that can be done by programs. C, we can introduce errors that way. So we'd much sooner code a solution. So let's code a shell script to fix this problem. I'll actually do it in the directory above to avoid problems. Call it fix file names dot sh. You'll call it for uppercase file name in asterisk do. All right, we're not sure what we're going to do, but let's get a loop working and go from there. It was called fix file names. Why isn't it tab completing? My shell has tab completion on and I'm hitting tab. Why isn't it tab completing? Wait a minute. Oh, a tab completed there. And now it tab completes. Did you know that? Oh. So it only will tab complete for executable commands if it's in the first position on the command line. That's sort of cute. I think it's cute. All right, let's try running my program. All right, so we've got a loop that executes once for each file name. Now what? How do I get the file name from uppercase to lowercase? You're saying, Andrew, call the .lower method of the string. Sorry, this isn't Python. You're saying, Andrew, hash include ctype.h. No, sorry. What's the shell way to do it? TR. We can check it out. TR lets me do arbitrary mappings of characters. So I want to map A, C, and K to Z, Z, and Z. I can do that. What? All right. So it's not often you really want to do that sort of thing. But let's try that out. All right. So now I'm about this shell problem. I've got what I want, but it's coming out of bytes on stood out of TR. How do I get that into a variable? You're saying subprocess dot check call and then use p dot stood out. No. It's actually easier. Backwards say, between me is a shell command. Saying, Andrew, I can put a while loop in there. You can. That's one of the things you can do, but shouldn't. Arbitrary shell command gets run, its output gets collected as a string and put back in that variable. Oh, remove the uppercase one. All right. What are we doing? That's not too bad. Does that make sense? No? It's not that hard. I think in principle this works, sort of. There are one or two bugs. In fact, you're not allowed to go home until you've found, I think it's 5 bugs in that program. There are a number of serious errors in that program. Though in principle it works. So let's try it. My directory has these files in it. Let's try running it. The fixed file names. Oh. Oh! All right. Now, someone asked, I think in the first lecture, should we install Linux? I think I said, yeah, installing Linux is a great thing to do, but say if your mum's got a $2 million e-commerce business she runs from home, don't get her server and start partitioning the disk. The same would apply here on a slightly smaller scale. When you're testing out a shell script that alters files, perhaps move somewhere where the files aren't so important, and make sure you've got backups. So what went wrong there? Don't actually know. But I've copied it to the lowercase first, there. So I've got the lowercase file name. No, that's the way copy goes. Copy is source, I think. Yep, source destination. Between the back quotes. Oh. Oh. Have you heard his theory? He's saying, I've left something out there, an echo, and it's actually trying to run all the files in the directory. But what if that, one of those files contained rm-rf/? Oh. So, if we're working on something like a shell script, and we stuff up, we could dismantle the file system. So there would be a number of morals one would draw here. Backups, excellent backups. What would Dropbox let you do for free as a student? A gigabyte or something ridiculous? And there's also Google and Microsoft competing with them. And USB keys. How much can you fit in a $5 USB key? As well as backups. Another lesson? You could remove the current directory from your path, yes. It's a convenience thing, but you'll notice if you go and talk to the system people at CSE, none of them have the current directory in their path. Why is that? Because they might sometimes have to CD into, say, student directories and fix problems. And if they go to run cat, and some student has got cat changed to rm-rf/ and they run that as root, that would be very, very bad. The other thing would be never debug a shell script as root. There'd be a couple of lessons. All right, I've got to recreate these files. Bear with me, I've got to type them all in. It took a while. Oh, look, they're back. What did they do there? Xargs. Xargs, probably should tell you about, shouldn't we? I should add that to the lecture notes. That's bad. Well, there's so many useful things. Xargs is a really useful shell program. It takes the words on standard input by default and runs a program with those words as argument. So if you've got bytes in a stream and want to turn them into arguments to a program, Xargs is the go for you. It has some nice parallel options and ways of grouping and things like this. You can research that. All right. That's one bug. There's still a few to go. All right, this should work. What can go wrong now? No error messages, it must be good. ls, I'll look at all the files back in lowercase. Oh, my Harry Potter novels. All right. What happens? So if you check, what happens if I run that again? Think about that. Yes, I know it's 5 o'clock. It's been a long day. You had a maths lecture at 9 a.m. But still, think about it. Well, let's see if I got any Mars bars. Oh, look. Whole thing of Mars bars. That's for the... All right, so what does that program do? So we've already run it once and it's switched everything to lowercase. What now? So he knows, and you're smarter than him, aren't you? Maybe you're smarter than all of them. All right, let's run it and find out. They've told me, don't insult students, Andrew, it's not good. Particularly if the students are smarter than you. Oh, what happened? What's this going to print? My Harry Potter novels. Gone. So what's wrong with the script? It says convert the file name to lowercase, but what's the flaw in your logic in doing this? It's already in lowercase, isn't it? So lowercase string is the same. And then it says copy file A to say file A. We can show you the full horror. I can recreate the files. Sorry, let me page backwards. Oh, come on, I knew it was this far. It's not my day. All right. I don't know why my history's not working either. And we'll run it again. So it got, for example, variable.sh, converted to lowercase, did cp variable.sh to variable.sh. CP says, quality error message actually, those files are the same, Andrew. Why would it check that? Why would it check that? if you write a naive CP, the obvious CP program that you do when you meet files in first year programming, it says open file 1 for reading, open file 2 for writing, while not EOF, copy from file 1 to file 2. What happens if file 1 and file 2 are the same? All your data goes away because the open it for writing truncates it to 0 length. And then you go to read and there's no data there. So it's good that CP checks that, because otherwise if that might produce a 0 length file. But then I removed the file. I removed the uppercase file. All right, I'm on this. So it's if, we'll have to come up with it, if then indent. Please don't make your tutor cry. Indent shell scripts just like any other program. And we can use test here. All right. Oh, let's do that. Oh, didn't do this right. This time for sure. So if the two strings are different, we'll do the copy. All right, I'm going to take a short break from talking, and you're going to think of 3 different problems with this program at least. I think there might be 4 or 5. That shell script works in principle, but it's got bugs. It'll lose data. Think about ways this program will either break or destroy data, or both, in the 5 minutes while I stop talking. Good. Send me an email and remind us I did the forum on Friday, so that was Friday, and then you will make it on Friday. You did your transcript now, but you're enrolled on MyUSW. Right. If you send me an email reminder, I'll at least send out more invitation. Talk to other students about what's been said in lectures, what the tutor, no worries. All right, let's start again. If you could try and stay awake for a bit longer. By the way, I just checked my email on my phone. That script we were checking, in the broken version, it managed to send me about 100 emails. So email is coming off the laptop. So there are 100 emails in my email saying, buy tickets now, Andrew. So we actually had a problem with the 2041 assignment the year before last, where a student set up emails on their website, but their website was broken. 2 years ago, I think it was Facebook. You had to implement a subset of Facebook, and they used real ZIDs in email. No, they made up what they thought were fake UNSW emails, but one was really the Dean of Law. And which was okay, except their website would send 150 confirmation emails because we had a bug. And I got this email from the Dean of Law saying, why is this happening? I had to apologise a lot. But the moral there is, if you're doing scripts that send out lots of email, or send out emails, try and print out what they're going to do until you're really sure they're working. All right. So I said this script sort of works, but it has bugs. It will destroy data or break in a number of ways. You've got to show me at least 3 of them, or I'm not going to let you go home tonight. So, yes, detention. You didn't know they had detention at university, did you? Maybe we should have it. All right. Suggestions. What could go wrong with this script? Yep. If I had directories. So it does, the script doesn't work for directories, does it at all? CP would fail and the RM would fail, I think. Yeah, but all right, so that was actually one I'm not thinking of. So the script does not handle directories. One. Oh, well, I'll fix that even. I said I needed to show you some cool shell scripting for, if you go out, you're at a party on the weekend. Let me show you this trick then. Actually, let's, I think I've removed everything. Oh no, where are we? We are there. Yes, before you go RM star, that would be another of Andrew's little life lessons, would be check the directory again. My favourite one, by the way, is shutting down machines and actually being secure shelled into the wrong machine. I've done that a number of times, including shutting down a machine on the wrong continent. Which is embarrassing when you have to call someone up in the middle of the night to say, can you restart my machine, please? All right. So I make a directory. So I haven't written that line above. Oh, it's in lowercase, so it doesn't want to do anything with it. But we'll put it into uppercase. And now it'll break, we think. All right, so it's breaking. And I just don't want to try dealing with directories, so I'll say this. Test if the uppercase file name is the directory, and continue. So that follows from that logic we showed you. You could do that as an if statement. There's no doubt someone thinking, oh, Andrew, you should do that as an if statement because it's more readable. Yeah, I like that, but some people would say that. All right, I'll give away a Mars bar for the idea of a file name being a directory. 1. Let's keep going. We need several more problems with this script. Yep. Oh, stop there. All right, so the suggestion is 2 files. Let me junk the directory. Even be more careful when you type this. For those that don't know, that's a recursive remove of everything in the directory. Typed in the wrong directory, it's not good. All right, so we want to create files called, say, Andrew and... Actually, let's make it a bit more obvious. We happen to have 2 files with different capitalization. Both important, both with data we need, and we run this script. In fact, let's suppose we have 3 files. There's another one. How many files will we have when the script is finished running? 1. 3 files before, 1 file after. It's not good, is it? Let's just check it out. Two files gone. No. And maybe my job gone. That's not good. All right. Yes, I can't. You see, even if I can throw that far, which I can almost, it'll intersect the roof. Who's got a good throwing arm for the relay throw? The guy in grey there? You've got to throw to the back of the lecture theatre. So keep going. No, turn around. It's not yours. You were. Hey, keep it going. Who caught it? Oh, has it got the right person? Yes. Oh, good. Thank you. Sorry, I thought it was... Oh, you... Not enough space on this. Hold that thought. We've got to fix the last bug. How are you going to fix this bug of 3 files going to 1?
If the file already exists in the directory, we rename it like 1, 2.
The rename is tricky. I'm not sure I can do that in the code that'll fit on the screen in a lecture theatre. So you can figure out how to do the rename. It needs a loop because you may have to do multiple renames. One rename would be easy, but you have to check whether the file you're renaming to doesn't exist. And then you have to check, if you have to rename that, you have to check whether the file you're renaming that to doesn't exist. So you have an issue there. But what we can do is just stop. All right, so we check to see before creating, we check to see that. Oh, we've got to do the touch. Where's to create the file? Oh, that'll do it. All right, so we've got 2 files. We try and run the program now. Look at that. Not creating it. Something you almost always should do with this sort of thing. All right. Other ways to do that? CP, by the way, has a very useful option, which is the no clobber option. So you can specify the -n option to CP. But then you've got that RM there, so you might worry about that. All right. Oh, actually, I could reword this, couldn't I? Wait a minute. I know how to do this better. It's one mark of good programmers is they are very compulsive about this sort of thing. Is that better? That's using test not option. So that's saying test that does not exist. All right, where are we at? That's our second bug. And from the back of the lecture theatre, another relay throw if he's right. The suggestion was there might be an issue if the disk were full. Not much I can do about disks being full, but it just won't create the files, will it? What will happen if the disk is full? Think about it. He's suggesting there are serious issues with this script if the disk is full. Is he right? Who's on his side? Who thinks he deserves the Mars bar? We've got one, really. That's 2. Think about it. Come on, think about it. He is right. He really is right. What does this program do if the disk is full? The CP will try and create a new file. What happens to the CP if the disk is full? It gets an error from the operating system. It'll exit with status, a non-zero status, and it'll say error disk full or something like that. I'd try and fill the disk, but it'll take a little while. Wait a minute, can I fill the disk? How fills my disk? DF dot. Oh no, it'd take too long for me to fill the disk. But you can see what would happen anyway. So the CP will fail. Does RM fail if a disk is full? No. What will happen to the next CP? It might actually work. So you could sit in this little loop where the disk is full, destroy one file. Oh, a bit of space on the disk. Copy that file, and then maybe the disk will fill again. So you may destroy a random subset of the files. Oh. All right, who did the last relay throw? That was good. Who wants to do the relay throw? Come on, step up. Yeah, whoever catches this has to relay it to the back row. All right. Oh, excellent. Wow, almost so close. As I've said, I've noticed there's no correlation with your ability to catch Mars bars with your ability to earn Mars bars and hence be good in the course material. What do we do about the disk being full? What's your solution? Hint, you can do it in 2 characters. If you're awake, nudge him, nudge him. What's your solution? Should you have been dozing? No, you should have been thinking. When do I want to do that RM? Only if I know the CPs work. I don't want to destroy my data, so I only want to do it if the CPs work. Only if the CPs exit with a status 0 to say, Andrew, everything was okay. Now I could do it like this, so I wasn't thinking. If $test $, equals 0, then, and that in some sense is probably a bit more readable. So $, special variable with the exit status, check that 0 and then do the RM. That would solve the problem, but there's an easier way. The one I like, you could do it with an if statement and the CP, of course, as well. But the one I like is that. Just do that. That is the biggest weakness. You see people have learned to shell program, but don't write good shell scripts. Sometimes it doesn't matter if they're just writing little one-offs that solve a task. But it's one of the most common weaknesses you see in people's shell programming. They don't use double ampersand enough. And it works all the time until suddenly they do something like they do a CD and then they do an RM star, but the CD fails and they do RM star in the current directory or something like that. So beware of that sort of thing. So that says only if the CP's worked, do the RM. And that not only caters for his disk full, but it caters for other things we might not have thought of. Not only our known unknowns in Donald Rumsfeld speak, but our unknown unknowns, if you know what I mean. I think that's 4, is that 3 bugs or 4? I think it's only 3. We want at least one more. You know you did one, you don't get another one. All right, you may have to get, it's like, you're sitting next to him. All right, Ben. Oh, see, I wasn't thinking of that one as well. Hidden files. What's a hidden file? What does he mean? Windows has hidden files. Linux doesn't have any hidden files, really. Linux operating system doesn't have hidden files. Linux operating system does not have hidden files. The Windows has something, I think, but starts with a dot. Does the Linux treat files that start with a dot specially? No, definitely not. No. Linux doesn't, but the shell does. How does this, yes, well, you're saying, Andrew, you're being pedantic. No. Let me go through this once more. You know, you're at home with your mum. No, you don't want to be pedantic about anything. She says do something, even if you just do it. But if it's a technical thing, being pedantic, being precise is important. So, by the way, this was applied to your girlfriend/boyfriend as well. But anyway, just a bit of helpful life advice from Andrew. But this is a good place to be extremely pedantic. So it's not the operating system, it's the shell. And what does it do with dot on the first character of files? If you do an asterisk, dot doesn't get included. Are we doing an asterisk? Oh, look, first line for uppercase file name in asterisk. So it won't fix dot file names. All right, so you can have a, just giving away the Mars bars today. Actually, it's not just the shell, is it? LS by default doesn't show them either, does it? And there may be a few other programs that don't show file names with dot. Why? Why is that? You knew about them. Why? Why is it? What's the reason?
It's a convention.
But why is there a convention? Why? Sorry, you'll have to speak up. I'm hearing. Dot, well, that's one reason is that there's these dot and double dot, these links to other directories, so it doesn't want to include those or show those. True, good point. But there's also the idea is that you want to be able to hide some files from normal users. I'm not sure if there really are any normal Linux users, but it gives you the opportunity of doing that. There's still one bug. How can a shell script have so many bugs? No, you've had your turn. One more. There's a classic shell programming bug here. It's perhaps the most important one to show you. So most of these have been really important things to show you, really major issues, and not necessarily just with shell. What sort of file name could still produce problems? The file is a command. All right. It's a good thought. It's something you'd want to test. All right. Let's get rid of those two. Touch, CP, RM, sure, GCC, LS. Ooh. Yeah, if I've got dot in the current directory, yes. That's a bit of a worry, isn't it? You're saying my shell script can break depending on the path. Remember, when a shell runs a program, it looks in the path. So someone with a weird path runs my shell script, it'll break. Let me show you that. That's actually worth showing to you. Let's remove these. Let's check, is dot in my path? Oh, dot will be in my path, but down the end of my path, I bet. Yes, I'm no idiot. It's right down the end of my path. Let me show you. Let's put a file in this directory called, what will break the shell script? I guess we'll call it, we'll put it for R. Oh, all right. Yeah, RM's good. We'll change RM to just say, there we go. Excuse me. All right, if I type RM now, it's still running the system one. Still running user bin RM. Why? I look at my path, and I'm not crazy. I've got dot in my, oh, there's my path further up the screen. Dot's in my path, but at the end of my path. So I can still get caught effectively by typo squatting, if you like. If someone puts the misspelled commands there in the current directory, they might get there. But if I spell a command properly, it'll rerun. But let's change the path and export it so it goes. Oh, I don't think I've shown you that either. Like that. Now if I type RM, oh, I've made a mistake in it. Huh. Oh, there's a trailing back quote. All right. Now if I type RM, I get that shell script. And if I run this program, it'll run that RM. Oh. That shouldn't need to run the RM. So this is something to remember with shell scripts. You put all these programs in your shell script, in your commands in your shell script, and you're expecting the real CP to be run, the real RM, and so on. But it depends on path being right. It's not the only environment variable that can affect your shell script, by the way, but it's a nice one to show you. So if one were a paranoid programmer, and I've said pedantic programmers are good, paranoid programmers are also, it's another one of these attributes. They're not normally good, but it is in a programmer. Obsessive, paranoid, pedantic, all negative attributes in many contexts, not in programming. So what a paranoid programmer might do is something like change the path like this. Forcing that. And that's actually pretty common in shell scripts people want their shell script to be robust. That now won't run that stupid RM. It'll do what it's supposed to do. All right, let's touch CP, run the fixed file names. Oh, wait, if? No. Ooh. There we go. It's better. One more bug. Just one more. Oh, sorry, you don't get a Mars bar for that. It was a nice thought, but it's not actually a bug. Something about file names will break this program now. You know, you two have had yours. Someone else has got to contribute here. Come on. You remember how I said you're really smart? I really did mean that. Even this guy is really smart. He's frowning at me now. All right. What was the suggestion for over here? Is it a good one? If the file name has spaces. All right. Suggestion is a file name has spaces in it. Oh no. RM is protecting itself. What do I do there? Oh, it's not in user bin. So there are two directories, /bin and /userbin, which I don't know why there are still two directories really. They used to exist when a disk wouldn't hold enough from one of them, which is so far in the distant past. I guess tiny, absolutely tiny embedded systems might still have, no, I don't think it's even the case there. All right, all the files are gone. All right, we want it to be, we'll make it hello world in uppercase, with some uppercase, which should be converted to all lowercase. What will the program do? And so if you've been drifting off a bit, this is hugely important. It's not something you'd expect, and it's not so good either. Right, the error message is coming from line 6. And line 8. It's saying, hello, unexpected operator. Now here you have to understand what the shell does. You'd expect, you really would expect, that you put a variable there, it becomes one argument of the program. So you'd expect $UC, whatever's in the variable UC file name, would be in argv2 for test. No, no. What the shell does, and let's be very clear about this, it expands the variables, replaces them with whatever their contents are, and then looks for white space to break up into arguments. So if that variable has 5 spaces, it could become 5 different arguments. Saying it doesn't read like that. No, 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 it doesn't read like that. So this is where this is a particularly nasty feature of the shell. It's the source of many, many bugs because Linux programmers don't put spaces in file names. Now you'll know that people who type files names into GUIs like Microsoft Word so often put spaces in file names. You'll notice people like me who are programming never put spaces in file names on the command line. Never, ever. Because they know there's so much buggy software out there that'll break with spaces in file names, including some that I wrote. So, you can stop this. If you put double quotes around it, that will be one argument. Double quotes force it to be a single string and one argument. So that's now argv2 going to test. Now she's saying, Andrew, that seems a bit tedious. You mean every time you have a shell variable, I use a shell variable, I can put double quotes around it, unless you're sure it doesn't have white space in it? Yes, that's pretty much the case. So let's fix the program. And that. Gee, it's looking like I should have done a substitute, isn't it? And that. Oh my God. And down here as well, you mean? Oh. Shell's not seeming quite so friendly anymore, is it? Try that out. I've put all those double quotes in. I think I'm good. And hello world has become hello world in lowercase. So single quotes are LS trying to be nice. Watch this, by the way. It's a bit weird, isn't it? LS peeks at stood out and figure out if stood out is going to a file or a pipe and does one thing, and if it's coming to a terminal, it does another. Interesting. You can do that in the shell script too, but I'll leave that as an exercise. Whether it's a good idea or not is, yeah. All right. Have I fixed all the bugs in my program? Anything else you'd like to try?
I don't think we need the first if condition anymore.
I don't think I need the first if condition. Probably not, but yeah, I'm happy with it, leaving it there, even if it might be obsolete. There's still a major bug there, by the way, in that program.
Might not have permission.
Permission, yes, but my double ampersand catches that. So that was the good way. I mean, he was saying file system full, but if I go with double ampersand, rather than just checking for file system full, I'm good. Anything that breaks CP will result in the RM not happening. And I'll get the error message from the CP. Good thought, though. Anything else you want to try? You never said anything until now. Do I have to think of everything? All right, so that's not strictly a bug, but it's an excellent suggestion. Here. Oh, almost hit the student in front of you. That would have been bad. All right, this doing a CP in the RM, that was a bad idea. Generally, operating systems have a way to rename a file that's a lot lower cost if you're staying within the one file system. So if one of these is a 50 gigabyte file, the CP, unless the operating system's incredibly smart, is going to be incredibly slow. Whereas just changing the name can be done with a rename command. The rename command on Linux is called move. All right, why didn't I go with this initially? It wasn't that I hadn't thought of it. I wanted that CP, that sort of pattern, that issue with command 2, you really don't want to run it unless you've done command 1. That comes up so many times, I wanted to show it to you. So, sorry, move was actually better and avoids the issue in this case, but there isn't always a way to just avoid the issue, and you want the double ampersand in many circumstances. Let me create a file. Oh, and a new line. Let's not put a new line in the file. Can you have a new line in a file name? If you assume 7-bit ASCII, which of the 128 characters can't you have in a file name on Linux? Come on, I've shown, you've all seen it, you've all used it. If only for a week you've used a Linux system, the first thing you should be asking as inquiring minds, like his, would be, what characters can I have in a file name? There are 2 characters I think you can't have in a file name. What are they? 2 bytes you can't have in a file name. I'm going to keep asking questions like that, but you can think about that. Oh, sorry, I wanted to create that. What's happened here? Should be converted to lowercase. Oh. I've lost some spaces. How did that happen? Where did that happen? Where and how? The echo? Yeah. What happened at the echo? There's no double quotes there on the echo, is there? What does echo do, though, with its arguments? It prints them to standard out, writes them to standard out with 1 space between them. So our file name with many spaces got split into a file with many spaces, and echo echoed that, each with 1 space between it. So it was just pure luck that it worked on the previous file name, it just happened to have just 1 space. Oh, that's a bit subtle and weird, isn't it? And scary. I think there might be 6 bugs. There's actually one more I just thought of. Anyone, I'll give you a chance. It's a 2 Mars bar bug if you can come up with this one. All right, it's not the same as, $100,000 for a 0 day, but 2 Mars bars. There's something that can break that move, for example. Oh, up in the far corner. Yep.
Can one of the file names include characters that made it look like a directory?
How do you look like a directory? Directory names are the same as file names. Linux doesn't have, it's an interesting line of thinking. / doesn't mean anything on Linux. Can you put a / in a file name? No, you can't. The two characters I believe you can't put in a Linux file name, by the way, are a 0 byte and a slash. So you can't make a file look like a directory in that sense. For good reasons, because it breaks so many things, including the way the file system works in the kernel. Good thinking, but no Mars bars. I'll give you a clue. That's my clue. So we've seen, someone's got it. No spoilers, no spoilers. I've given you my view on spoilers. So we've seen programs like ls take, you say ls files or directories, but you can also supply options. How does ls tell what's a file name and what's an option? By convention, a dash. A dash. And lots of Linux programs do this. So when they want to have special arguments, they say put a dash in front of it. Oh. And move, what are its options? So move has a few options like interactive, no dash, no clobber, and so on like this. So what happens if I create a file called, oh no, I can't create a file called -n because touch thinks it's an option. It's saying, Andrew, there's no capital N option to touch. Wait, I'm on this. Oh, why didn't that help? Why didn't that help? This is going to be an ongoing theme in this course. Who interpreted those quotes and how did it interpret them? Bash interpreted those quotes. Bash interpreted those quotes and it's saying, Andrew's saying, don't attach any special meaning to these characters, just pass them through to the command. I would have done that anyway. Okay, that's all right. Passes them through. So that says to bash, don't place any special interpretation on the command as characters, but it's touch. Touch is the problem. Touch sees the dash and thinks this is an option, but I just want to create a file called -n. I could do it just like this, for example. That would work, but all right, I'll do it like that. Will that work? I don't actually know. Ooh, look at that. All right, so I've just got a file called -n in this current directory. There are a lot of shell scripts that will break with this sort of thing. A lot. So let's try running my program and see what it does. What are you going to do about it? What are you going to do? So we're running this, but the file name starts with a dash, so move thinks it's an option, but it's not a valid option. What are you going to do? It's the prac exam. This gets you to a HD. What are you going to do? No, you've done too much. No. Someone else, some thoughts. Prove to me you deserve to be in this fine, fine university. She's saying, I don't. You do, honestly you do. But you've got to think more. Let me show it to you on the command line. Maybe a bit more obvious on the command line. So RM's got better. How many names does a file have in Linux? So this file could be called -n. I could also call it by its full path name, which happens to be that. Any other names I could use for it? Well, there's ./-n. Any other file names I could use for this file that'll work? There's one more. You can use double dot. So you can say double dot, which means the parent directory, then you can say this directory, then you can say the file name. But wait. And again, if you're at a party on the weekend, which you won't be, but if you were, let me show you something that will impress everyone as a topic of conversation. As an icebreaker, I think is the term. All right, so that's one name for the file. But look at this. I can say go up a parent directory, come down. Go up a directory, come down. Oh, it's the same file. So how many file names do we have? An arbitrary number. There's actually a fixed length on Unix path name, so it's not infinite, but it's large. There are many, many path names. How many of those begin with a dash that can be mistaken for an option? One. Just one. So you can choose any other path name out of all of these, and it'll work. All right, so we'll go with rm. We could do that. Is this a way to fix our shell script? It sort of is. It's not very satisfactory, but that would work. That would unbreak our shell script. That's only viable if that's in the current directory. If you're writing a shell script where that's a full path name, or might be a path name, might not be, you've got an issue. You need a way out there. The usual way out, many programs provide this, and let me check if move does. Oh, come on. Does it say it does? Oh, but it doesn't say it does, but it does it by default, I guess. A whole set of programs you can say, for programming purposes, you can say --, and that means no more options. Even if something from now on looks like an option, it's not an option. So it says turn off this special meaning. And that's the more robust way to do it. Saying, Andrew, I can't remember all of this stuff. Yet the lesson is not so much to remember it, but understand why it's happening. As long as you understand that string's coming in here, oh, and if there's a dash on there, there's going to be a problem. That's the message I wanted you to get. To be thinking about the steps, the interpretation, the process. If you understand that properly, everything else you can figure out. So that would be the robust way to do it. And you might need to do that elsewhere as well in that program. There are other tricks you can do. Questions? Yep.
How can I fix some files that contain non-printable characters?
Oh, you want to handle dot files?
No, just some files that contain the file names that have the non-printable.
Non-printable characters? This should work for non-printable characters, as long as you've got the double quotes. They're sprinting to get the bus. We should have a special 2041/9041 bus, shouldn't we? Yes, we should. Straight to Central Station from outside the Law Theatre. All right, if there are no more questions, thank you for your attention. I'll see you on Thursday.
In this semester, I have another lecture that classes from advanced